Contact 175, 22 miles, flight of 2, Angels 10.
Good evening, ladies and gentlemen. I'm Paul Wilborn. I'm the Executive Director of the Palladium Theater here at St. Petersburg College. On behalf of our President, Dr. Carl Cutler, and the faculty and staff of St. Petersburg College, I want to welcome you all to the Palladium tonight and to Cosmic Quandaries. We're really proud to be partnering with our good friends at WEDU tonight. I just want to ask quickly, how many of you have never been in the Palladium Theater before? Great, I love this. Hundreds of potential members. The Palladium just turned 10 this year, and we present the best in jazz, blues, classical, gospel, opera, and musical theater. We'd love to have you guys back to see us. In the lobby afterwards, there are cards you could fill out, and we'll put you on our mailing list. We only sell that to people who give us lots of money, so you won't have to worry. So please, fill out the card. We would love to have you get our monthly mailings and see what goes on here at the Palladium. We want to move on quickly because we're on a time schedule, and you didn't come to see me. Ladies and gentlemen, a few things you ought to know. This is going to be kind of a Q&A program, and you will be able to ask some questions, so get your questions ready. As you saw when you came in, there are going to be books for sale in the lobby. There is no intermission, so if someone needs to go to the restroom, let them out, let them go. We'll be going for about around an hour and a half. And finally, it's a real treat to be working, as I said, with WEDU and with my good friend who is the president and CEO of this great public television station that so many of us grew up with. Ladies and gentlemen, will you please welcome Dick Lobo.
Thank you, Paul. And on behalf of the WEDU board and staff, it's my pleasure to welcome all of our WEDU friends and supporters here tonight, as well as our special guests from Boston and New York, representing one of PBS's most popular series, Nova Science Now. And I also want to welcome our area scientists from the Bishop Planetarium and the St. Petersburg College Planetarium. This year, WEDU celebrates its 50th year of broadcasting excellence in West Central Florida, and we began as a small educational channel in 1958, and today we're proud to be one of the most respected PBS stations in one of the most dynamic communities in the country. WEDU has grown and changed significantly over the years, but we've stayed true to our educational roots, as you're going to see tonight during our exploration and discussion on Cosmic Quandaries. And I'm pleased to announce that due to the popularity of Nova Science Now, hosted by Dr. Tyson, the program is now going to have a new dedicated time slot in prime time beginning Wednesday, June 25th at 9 p.m., an excellent time period for this excellent program. We hope you'll watch and stay tuned. In addition, just before you all arrived tonight, WEDU produced a special half-hour interview hosted by our own Rob Lorai with Dr. Tyson and his executive producer, Paula Apsell. That's going to be airing sometime in June, so keep an eye out in the listings for that program. And then tonight's discussion will be streamed on our website, wedu.org, probably in a couple of days, so please be on the lookout for that. Tell your friends about it. And let me thank my good friend Paul Wilborn, the Palladium Theater, and St. Petersburg College for partnering with WEDU on tonight's terrific event. I want to thank all of you again for your generous support of WEDU over the past 50 years, and I invite you to join us as we move on to multiple media platforms in the new digital age to come. Thank you for being here. Good night.
Thank you, Dick. What a great asset to WEDU he's been. All right, let's move on to our program. We're first going to introduce our two panelists. Dr. Jeff Rogers. Dr. Rogers, come on out. He is the director of the Bishop Planetarium and director of education at Bradenton South Florida Museum. He began his career at American Museum of Natural History and the Hayden Planetarium. Next, Dr. Craig Joseph. Dr. Joseph, come on out. He's received all his professional degrees from the wonderful Ohio State University. A local favorite, obviously. He did his dissertation on stellar evolution and computer modeling of stellar interiors. Ladies and gentlemen, I'm here representing the English majors of the world. He's taught at Bowling Green and Southern Missouri State University, and since 1996, he has been at St. Petersburg College as planetarium director and professor of astronomy. Thank you very much. And they're going to have some questions for our special guests a little later on. Now I'd like to introduce Ms. Paula Apso. In PBS circles, Paula needs no introduction. She is legendary for a woman so young. Paula, come on out. Paula is the senior executive producer of NOVA and director of the WGBH Science Unit. She has built this incredible program into just the program it is today. I believe the interesting part was you were hired out of Brandeis University to type the public broadcaster's daily television program logs. She has moved up from there, ladies and gentlemen. Along with NOVA, she has overseen production of the 8-part miniseries Evolution, which I understand when it was broadcast in Florida was called Evolution, maybe, maybe not. Sorry about that. In 2005, she introduced the NOVA spinoff, NOVA Science Now, and that's what brought you here tonight. And now our also other special guest, Dr. Neil deGrasse Tyson, respected scientist, author, and director of the Hayden Planetarium in the Rose Center for Earth and Space at the American Museum of Natural History. We're going to let Paula talk a little bit more about our special guest when he's up here giving us his cosmic perspective. So let's have a hand for Dr. Neil deGrasse Tyson. When we were given several dates to hold for this event, I asked, well, what should we call the event on our hold? And I was told, just mark it Sexy Astrophysicist. Ladies and gentlemen, you be the judge. He's married. Paula, would you like to come up and introduce our special guest?
Thank you very much, Paul. And thank you all so much for inviting me here to WEDU and to this fantastic theater. I have to say that the weather certainly beats the weather in Boston. But mostly it's a treat for me to spend time with folks who support public television and WEDU and make programs like NOVA possible. Now, I hope that all of you are familiar with NOVA, but I bet many of you don't know that this year is NOVA's 35th. That's an eternity in television. My daughter, who's a soap opera fan, is pleased to know that General Hospital Has a Safe Lead went on the air almost 45 years ago. But NOVA has outlasted many classic television franchises, including shows like Seinfeld, I Love Lucy, MASH, and Friends. And despite the influx of cable networks since the 1980s, NOVA remains unique on the television landscape as the only weekly documentary series dedicated to telling important science stories. In fact, after the journals Science and Nature, NOVA is the nation's most trusted source of science news, according to a National Academy of Sciences report. This puts us ahead of such venerable print sources as the New York Times and the Wall Street Journal. And you can bet we really like that. Well, in the TV industry, it's always better to show than to tell. So to start off our discussion, let's take a look at this selection of clips that gives a pretty good sense of the breadth and excitement of the science that we cover in our series.
slip and that's it. You're going to die, you're going to pull off everyone with you.
My first reaction when I saw this mummy was, oh my God, it's a pharaoh.
There's the tornado.
You will see why tornadoes form.
He had this beautiful vision that the flying machine would bring about world peace.
There's real value in seeing a corner of the world that throws ordinary existence on its head.
This, in fact, was the first flower in the world.
We can help shift the world onto a path that is one of shared prosperity.
It is the key to curing disease.
Well, that's history right there.
We live in an era when technology moves like never before. Advances in biology are changing the way we understand life. Climate change could alter our whole existence, and whole planets have been known to drop out of the solar system. We're lucky tonight to have with us one of the people responsible for demoting Pluto from full to dwarf planet. He is, of course, Neil deGrasse Tyson. And when he's not busy picking on tiny, faraway objects, Neil is an astrophysicist and director of the Hayden Planetarium at New York's American Museum of Natural History. Simply the best ambassador of science that I know, Neil is also the host of our new magazine series, Nova Science Now, which begins its new season on June 25th. So that you can see Neil in action, I brought along a promo we've been airing recently to remind people about our new season of shows coming up this summer. Let's take a look.
I'm Neil deGrasse Tyson, host of Nova Science Now. You ever wondered what would happen if you dug a hole from one side of the Earth, through the center, out the other side, and then jumped in? Before we show you, a few disclaimers. If there was any air in the hole, air resistance would slow me down. So let's ignore that. Earth's molten core is 11,000 degrees Fahrenheit. On the way past, you'd simply be vaporized. So let's ignore that too. We would also have to ignore Earth's spin, which would make me ricochet from side to side down the hole. And please don't try this experiment on the actual Earth. All right, here we go. I fall, gaining speed as Earth's mass pulls me towards the center. 14 minutes into my fall, halfway to the center, and I've accelerated to more than 15,000 miles an hour. Here, there's only half the force of gravity than on the surface. So I'm still gaining speed, but at a slower rate than when I first jumped in. 21 minutes into my fall, and I'm at the center of the Earth, and going my fastest. About 18,000 miles an hour. As I pass the center, gravity now works against me, slowing me down. And by the time I make it halfway between the core and the other side of the Earth, I'm back down to about 15,000 miles an hour. It'll take only 42 minutes to make the entire trip to the other side, at which point I'll slow to a full stop. Just like when I started, all of Earth's mass will pull me back towards the core. Unless somebody catches me, I'll fall down the hole again and yo-yo back and forth forever. Thank you.
No problem.
Nova Science Now returns this summer.
All right, I have to admit, the T-shirt, the jeans, the eye thing with Jon Stewart, sexy. And we're going to do Q&A to start off with here and sort of go from there. Dr. Rogers, would you like to start us off?
And you were, in fact, the one responsible for that opening salvo in the Pluto Wars back in 2000. When you put the planets up there, you failed to put Pluto up as one of the major planets. Since then, this has played out on the international stage.
Clearly hasn't gotten over that fact.
I have not. Well, those of us still out there, we hear it all the time. We've since decided that debate. What I want to know is, are you satisfied with the end of that debate? And if so, what have you got to say to all those Pluto lovers out there?
Just so I get a sense of this, who here is a Pluto lover among us? Just raise your hand. Okay. What I have found is that among Pluto lovers who retain some deep level of disturbance over this decision, most of them do not know, for example, that there are 6 moons in the solar system bigger than Pluto. Did you know that? I got some hands. Okay, that's some starters. We'll just begin there. Then we find out Pluto is more than half ice by volume. So that if you brought Pluto to where Earth is right now, heat from the sun would evaporate that ice and it would grow a tail. That's no kind of behavior for a planet, I think. We have words for objects with tails. We call them, well, other than tailed mammals, we call them comets. Okay. So, what happened back then in the 1990s, because we did our homework on this, the 1990s, research in the outer solar system discovered other objects with orbits that kind of look like Pluto's, because Pluto has a weird orbit. It's tipped, it's oblong, it crosses the orbit of Neptune. It's a misbehaved object in the solar system. It's always been that. Didn't recently become that. And so you discover these other objects in the outer solar system, running up into the hundreds, will shortly be in the thousands. They all are icy, like Pluto. They all have cocked orbits, like Pluto. 3 of them are bigger than Pluto. And so we realized in the 1990s that Pluto was the largest of a new swath of real estate of objects out there. And so in our exhibitry, rather than enumerate the planets, as is so common, there's no science in the enumeration of the planets. You have school teachers giving exams saying, what is the name of the 4th planet from the sun? And all the students dutifully memorize, my very educated mother just served us 9 pizzas, recite that, pluck out number 4, put it as the answer, as though that's science. That's not science. A parrot could do that. And so what we did was, rather than enumerate the objects, we grouped them by like properties, creating families of objects that populate the solar system. The innermost terrestrial objects, Mercury, Venus, Earth, and Mars, we have more in common with each other than any one of us has with any other object in the solar system. There's a class right there. Then you get the asteroid belt, separating Mars from Jupiter. Craggy chunks of rock. They have more in common with each other than anything there has with anything else in the solar system. The gas giants, Jupiter, Saturn, Uranus, and Neptune. Huge, low density, gaseous. And then Pluto and the rest of its newly discovered brethren. So I think it's happier out there, really. No, it's one of the kings of the comets. True. It used to be like the puniest planet. So our exhibitry simply didn't count the planets. We showed the solar system as this grouping of families. And some people just never got over that fact. But that was a trend line that was already in progress. We were the first to do it publicly. Then we got raked over the coals by the newspaper. Page 1 of the New York Times. Pluto not a planet? Only in New York. And so I got this mail. People saying, hate mail came into my office from like 3rd graders in crayon. Why did you kill my favorite planet? Cover letters from science teachers. Packaging the letters together. All angry. All pissed off. Pissed off elementary school. I didn't know they could get that angry. I didn't know they ever had anything about which to get angry until this happened. So now they're all in high school now, okay, with other issues to worry about in their school day. And so turns out the next generation of third graders are now born into this new awareness that Pluto has family out there. And so the hate mail has stopped.
Good.
I'm happy to report.
Good.
Yes. But can I say, I just last week submitted a manuscript to my publisher called The Pluto Files. Odes, emails, and epitaphs in the name of a fallen planet. And it's got the hate mail. I had to put it out there. I had to show people, and it's not just the kids, there were like adults fighting about this as well. Colleagues, took sides. So it became a sociological phenomenon. Remarkable. That people would get that bent out of shape. And Americans cared more about it than the Europeans, I found.
Well, it was our planet.
Well, no. By God, that's out. You're not going to demote an American planet. Like Stephen Colbert took that same attitude.
It's our planet.
Discovered by Americans, for Americans, by golly. But I think that it's clear why it matters more to Americans than to Europeans. Because I think most Americans don't know that an American discovered Pluto. But they do know
Pluto.
That Mickey has a pet dog
That's right.
named Pluto. This audience wouldn't know that, okay? Because this is a PBS audience. But everybody else knows Pluto is Mickey's dog. And so you start messing with Disney characters, those are fighting words in the American culture, just letting you know. And while we're on the subject, you started this, but while we're there, I'm going to tell you, I was deeply disturbed to learn that Pluto was Mickey's dog. Because I work in a museum, the American Museum of Natural History. I happen to be in the astrophysics group, but I have this osmotic connection to the rest of my colleagues there in mammalogy and paleontology. And so there's something wrong with the mammalian order of the world that a mouse can own a dog. So I was deeply upset. So I was, because I'm writing this, I'm doing the homework on it. So I called up Disney. I said, what gives here? And they had the answer. Do you know the answer? No, you wouldn't know because you're a PBS audience, right? You don't know Disney, okay? So, why is that the case? Because if you are a Disney creature and you wear clothes, you can own other creatures that don't. So Mickey's got that jacket and sometimes got that bow tie, sometimes he wears clothes, Pluto runs around butt naked. Mickey can own Pluto. But Goofy wears clothes, and he talks, so he can own other pets. So that, I know you were burning to know that, but, so that's the story. The International Astronomical Union, 6 years later, ended up basically agreeing with our point of view, and that offloaded some of the anger that was coming our way, and it went to them, which I was happy to report on. So that's.
Let me get this straight. Mammalian order. I want to talk to you about that a little later.
Okay,
I like
sure.
that phrase. That's good. Dr. Joseph, I think you've got the next question.
Oh, yeah. So first of all, on behalf of everybody here at St. Petersburg College, welcome to the Palladium.
I'm happy to be here. Thanks. Gorgeous spot.
One of my favorite pet peeves is Hollywood science. And I can rattle off...
Don't get me started on Hollywood science.
I can rattle off any number of science fiction movies out of Hollywood that portray really, really bad science. And I think probably most people's perception of science comes from what they see in Hollywood movies, perhaps. Do you have any...
Nova.
Oh, well, yes. Okay, that's absolutely right. That's absolutely right. Now, do you have any favorite Hollywood movies? Well, actually, I know you have one favorite at least.
Wait, favorite bad movie or favorite good
bad
movie?
Science movies.
He started me. I'm not accountable henceforth. Okay, because you started this off. First of all, let me be clear. There are movies out there where the director just doesn't care. And if they don't care, why should I care? All right? I'm okay if they don't care. It's when there's a premise of accuracy and precision that they just mess up. That pisses me off. Okay? Can I give you an example?
Please.
Back up. I was in graduate school when the Disney movie The Black Hole came out. One of my 10 worst movies ever, on all counts.
Worse than Armageddon?
Armageddon was at least fun, even though the asteroids in Armageddon seem to have really good aim, you know. Like, one hit the Eiffel Tower, you know, another one hit the Hoover Dam. I'm thinking, these are like asteroids with GPS, you know? I mean, what's going on here? So, space shuttles launching space shuttle can't leave low Earth orbit. They got everything wrong. So much wrong that you just gotta let that one go, all right? You let it go. And the black hole, they could have called me up. I could have hooked them up big time with cool black hole stuff, and clearly they didn't care. And I looked in the credits, I'm a credit watcher, no science advisor. Okay, I could have hooked them up, but that's not even what I want to tell you about. You got me started. I may have been one of the last people in the world to see the film, to pay to go to the movies to see the film, The Titanic. Okay? I was like one of 5 people in the theater at the time. I figured time came, I gotta see the movie. Everybody else seeing the movie 3 times, I should at least see it once. So I'm there watching it. There it goes, fine. Much about this movie, to remind you, was widely marketed as having precisely captured the details of the ship. Because Jim Cameron, the director, hired this submersible, went down, found the ship, okay, looked at the designs of the wall sconces and the china patterns and the staterooms, captured all of that in his movie. So here's somebody who cares about detail. I'm going to hold him accountable. So, watching the movie, okay? The ship sinks. So I gave away the... Sorry. In case anybody out there didn't know. We know the day, the time, the longitude, the latitude, the date, the year. We know everything about how, when, and where that ship sank. Okay? There's Kate Winslet on the plank, singing deliriously as her boyfriend just sinks to the depths of the ocean. Why didn't he try to get on there with her? You know, you think they could have worked something out? You think? There she is looking up. There is only one sky she should have been looking at. And it was the wrong sky. Worse than that, it was not only the wrong sky, the left half of the sky was a mirror reflection of the right half of the sky. So it was not only wrong, it was lazy. And I'm thinking, this is wrong. Because I noticed, we noticed, you own stuff like this, you know the sky. Right, you know the sky. Yeah. You know the sky is your backyard. If it's not, it should be. And for a couple of dollars, you can buy a planetarium program on your computer. Check out the sky when the Titanic sank. It was not Jim Cameron's sky. That's right. So I pulled out my finest of letterhead, the one that has all the degrees and all the titles. I wrote a letter to Jim Cameron, politely saying, "How could you mess up the sky?" Got no reply. Figure. No reply. 5 years later, I'm on a committee. That intersects a committee that he's on. He was an advisor to NASA for a while, by the way. Not about the sky, about other things. About exploration, okay? He's a big explorer, by the way. And so, I'm in the room with him. I said, here's the big chance. So I said, Mr. Cameron, I wrote a letter to you some years ago. He never got it. I said, did you know that your sky was just wrong? And we know what that sky was. And everything else about your movie was so accurate. And he says, I didn't know that. I didn't know. In fact, that happened in post-production. And that was all he said. And I was just completely immature about it. I wanted him to grovel for forgiveness at my feet. But he didn't do that. And so somehow I was deeply unsatisfied by this. 3 years after that, he gets an award from Wired magazine. They rent out our planetarium to give it to him. Now he's in my place, all right? So in my irrational immaturity, I bring the subject up again. All right, it turns out I was invited to a dinner with him after that event. There were only 8 of us, he and a few of his friends. The wine is pouring, we're all kind of chilling. So I said, here we go. I said, Jim, because now I can call him Jim. Jim, I wrote you, this story will end, I promise, very shortly. I said, I wrote you a letter about the sky, and you didn't get it right, and why? How could you do that? And he answered. He said, well, last I checked, Titanic worldwide has grossed $1.3 billion. Imagine how much more it would have grossed had I gotten the sky correct. I couldn't leave well enough alone. That just shut me up. I said, I can't follow that. Nothing I can do. So I went home, tail between my legs. 2 months later, I get a phone call from some guy. I forgot his name. Some guy called me up. Said, hello. I said, hello. He said, I work post-production in Jim Cameron's studios. He's releasing a 10-year anniversary director's cut of the movie, and he's adding new footage, and he tells me you have a sky he can use. I said yes! It is possible to influence these things, as what was the case then and there. But otherwise, I don't cry about it because you just get really annoying to the people who sit next to you in the theater.
I think we're going to do a couple of questions from the audience as well. Is that where we are now, I think? We've got a microphone over here. Into the mic so you'll be on TV.
Okay, thank you. I was wondering if you could please comment on the mapping of dark matter and how it's being done and what you think dark matter might be.
Okay, dark matter. You may not know, or maybe you do, that 85% of all the gravity of the universe has a source that is completely unaccounted for. We look around at all the electrons, protons, all the favorite particles that comprise us and Earth and the sun. We find them, we know where they are. We know how to detect them. And when we do, and we look at the gravity that they exhibit, that's like 1/6 of the gravity that's actually exhibiting itself out there in the universe. We don't know what's causing it. So we have this placeholder term called dark matter. We don't know if it's matter. There are many of us who assume it for other cogent reasons, but we don't know if it's. So we could have just called it Fred, all right? It's just a placeholder term, okay? So we are completely ignorant of what accounts for this extra gravity. It's really dark gravity. That's what it is. We call it dark matter. Now, there's the old saying, if you're a hammer, all your problems look like nails. Because we have dark matter as an outstanding problem, if you're a particle physicist, they all think it's some mystery particle awaiting our discovery. If you're a sort of gravitational dynamicist, you might think that maybe our laws of gravity need modification. You're just applying the wrong formula to calculate how much gravity should be coming out of this matter. Put in the right formula, corrects it all. I'm agnostic there. My favorite idea, not my idea, but it's circulating, comes from the multiverse hypothesis, that we are one of many universes, which has important historical and philosophical foundations for suggesting we might be one of multiple universes. But there's no evidence for that yet. But let's go with that assumption for the moment. If there were multiple universes, they would exist in a higher dimension. So you'd have these universes coexisting with us in a higher dimension, not intersecting. It turns out if you do the calculation, gravity can permeate the membrane of one universe and be felt across the membrane of an adjacent universe. So it may be that what we're calling dark matter is regular matter in a parallel universe whose gravitational field we are feeling. And so it's not always wrong to hypothesize. It's not always wrong to hypothesize things that you cannot measure directly, because you may be able to measure them indirectly. You can hypothesize that a bear is walking around your cottage in the mountains, even if you've never seen it, because after a snowfall, you see bear prints outside your house. Okay, well, okay, maybe that's an imposter. But then you see like a big pile of bear poop, okay? And so now you got it, all right? And so now you don't have to have seen the bear to suggest to yourself that maybe you should move somewhere else. So there are forces of nature that can reveal themselves without actually seeing them directly. That's my favorite hypothesis, but I'm not like lobbying for it. I just think it's the coolest among the hypotheses suggested. So that's dark matter, and whoever discovers what it is, that's a Nobel Prize waiting to be handed, right there.
And that's not the same thing as dark energy.
Well, it's not the same thing as dark energy. That's another aspect of the cosmos about which we are completely dumb stupid. There is 4 times as much dark energy as there is dark matter, of which there's 6 times as much of that as there is the matter that we know and love. So we only understand 4% of that which comprises the entire cosmos. So you can't be an astrophysicist and be big-headed about it, because we are staring ignorance in the face. And dark energy this is this pressure that exists in the vacuum of the cosmos that takes our expanding universe and has turned it into an accelerating expanding universe. The gravity of all the objects want to sort of slow things down. The dark energy is speeding it up. We don't know what's causing it. And it'll very shortly completely overrun all the power of the gravitational force there is in the universe. And all the galaxies of the night sky will accelerate to beyond our horizon. And cosmology as we know it would cease. And the cosmologists of the future, since they will have no galaxies to gaze upon, because the expanding universe took them out of our horizon, all the universe will simply be the stars of the Milky Way galaxy of the night sky. And they will look at old texts from previous years, and they will say, oh, this is what people used to say about the universe, about the galaxies that were in the night sky. Had there not been these books telling them about what used to be there would be no understanding of a Big Bang or cosmology or of the origin of the universe. So, there you have it. Oh, by the way, and so dark energy, since we don't know what that is, that could be just like, we have Fred and Ethel, right? Dark matter, dark energy, they're just placeholder words. We have no idea what they are.
Some of us know even less than others. Go ahead.
Yes, sir. My question is, even in your talk just now, where you talked about being pulled down into the black hole, and what in the reading they talk about this, I thought the black hole was like this minute, minuscule point, right? And there's not a down into it. So if you have an accretion disk, from what I've read, you show an accretion disk and being pulled into that, and it's all coming in a circle. What happens if you be flying over top of it and look down? In other words, what's below and above that plane that disk is on, or the galaxies that are not spiral like ourselves, do they have an accretion circle, or how does that work?
You mean accretion sphere?
Sphere.
Yeah. Does this bring angst to you? It's because you were kind of like getting all gesticular there, and I worry maybe you don't sleep well at nights until this is resolved. I should preface this by saying I'm very pleased you are all here this evening, because I don't know if you knew the numbers, but there's about 6,000 astrophysicists in the world, and there's about 6 billion people. If you divide those two numbers, you get 1 in a million. So if you ever have the occasion to be in the company of an astrophysicist, that's the time to ask all your questions, because you never know when that will happen again. Okay? Just want to let you know. All right, so. Sir, let's get a few things straight about black holes. When you are in the vicinity of a black hole, no matter where you are around it, down is the direction towards the black hole. If you're below it, down is that way. You're above it, down is that way. You're over here, down is that way. And it's the same way on Earth. Down is whichever way the center of the Earth is. So let's clarify that. Second, we call it a hole. It's actually a three-dimensional hole. You think of a hole in the street, or a hole that we dug through the center of the Earth, and you jump in. Normally you can sort of look at a hole from the side and below, because a hole, almost as we've kind of defined it in the dictionary, is a cut through a two-dimensional surface. That's what a hole is. No one says, put a hole in the middle of this room. That wouldn't make sense to you. If I say put a hole in the floor, that's a two-dimensional surface. A black hole is a hole in three dimensions. Every direction you approach it is down, and you're falling into it. The actual content of a black hole has collapsed to what we call the singularity. That's where, in Einstein's theories, we divide by zero. It's bad to divide by zero. So, Einstein's theories fail at the center of a black hole. That's why we know there's something beyond Einstein's theories. There's got to be. If the universe is a knowable, organized place, Einstein's theories have a limit, and that's the singularity. It'll get you right up to it, but it won't get you there. Meanwhile, the operational definition of a black hole is the region of space around it, within which, if you fall, you will never come back out. And we call that, poetically, the event horizon. Love that. The event horizon. I kind of feel you shouldn't, once you go and you never come out, it should be like the death horizon, the Death Star. But it's not the event horizon. So when we think of the size of a black hole, it's not the size of the matter that occupies it. It's just the region of space where if you cross that boundary, there is no hope of ever coming out, because the fabric of the universe has curved back on itself, and there's no trajectory you can take to get out of that region. Light can't even get out. That's why we call them black. And light is the fastest thing we know, so you're not coming out. Especially after what happens to you.
Spaghettification.
After the spaghettification. Right. One way to delay the spaghettification is if you tumble really quickly, like a rotisserie. Because then it can't systematically stretch you in one way.
Tuck and roll.
Tuck and roll.
Yes.
Yeah, pipe, tuck. A new Olympic diving maneuver, the anti-spaghettification spin. We'll work on that.
But spaghettification only applies to small black holes, right? If it's a big supermassive black hole, you could pass right through.
So actually the spaghettification for some black holes will happen before you get to the event horizon. For others, it will happen after you pass through the event horizon. But it will happen en route to the singularity. And it's a one-way, one-time experiment. Yes.
We got one here. Why don't you go over to the microphone?
Okay.
My question is, the next round of budget cuts has come through, and they've decided that NASA, NSF, everybody, gone. We got other things to concentrate on. And you go to Washington and beg and plead, and they say, okay, you can have one project. And with you in a position where you sort of got one foot in the scientific community and one foot in the public, what would you pick as that one project?
Good question.
I would say to myself that something has gone horribly wrong with the country. If the country cuts the budget of all its science agencies, which in that case would be the NIH, which funds health, the National Science Foundation, which funds the major branches of science that you learned in high school and in college, NASA, which funds our dreams, as far as I can describe it. If you remove all of that, then there's nothing left to inspire a next generation. And if I'm only allowed to pick one project, it would be to build me a boat to sail to the country that has decided that they do want to spend money on these projects. And I don't know if boats have rear view mirrors, but there will be America in the rear view mirror as people move back into the caves.
I think we've got a student over here. You?
Yeah.
Can someone help him get the mic down to his, there we go.
Will like a black hole be able to suck in another black hole?
Good question.
It's not past your bedtime or anything? Can I ask what grade you're in? And tell me your name, too.
Second, and my name is Clayton.
Oh, your name is?
Clayton.
Clayton. Hi, Clayton. You're in second grade, and you're thinking about colliding black holes? You belong in like 12th grade, okay? Don't tell your teacher I said put you in 12th grade, okay? So it turns out, while I was in college, there was a graduate student at my college, at my university, whose PhD thesis, this is what you do to get to become a doctor, not a medical doctor, but a professional research doctor in astrophysics. His PhD thesis was on the subject of colliding black holes. And what makes it an extraordinary problem to solve is that the distortion of the fabric of space and time around one black hole also exists for the other black hole. So you have black holes entering each other's event horizons. So I opened up that thesis. I didn't understand a single page in it. It's an extraordinary disturbance in the fabric of space and time. And it turns out, while I cannot reproduce the calculation, it's a level way beyond what I was doing at the time, and even what I'm doing today. But I can tell you that there are people who have recognized what severely distorted space does, what the effect that severely distorted fabric of space and time. They've studied what effect that has on the passage of time. And it turns out there is a path you can take around two moving black holes that haven't quite collided yet, where you can end up in the past of when you started that journey. So it's backwards time travel, according to calculations from Einstein's general relativity, is enabled by the severely distorted fabric of space and time, such as what you would get with black holes that came in their own proximity. And so beyond that, you really want to sort of watch that from a distance. And so you say what happens, they will eat each other, and they'll make a black hole that's twice as large as the one they started with. But it'd be quite a ride for any material that's swirling in its vicinity. So excellent question. Thanks for that. Mm-hmm.
Right here, go to the microphone.
That gives new meaning to the phrase, kick you back into the ice age.
Oh, yeah, kick you back before you were born. And by the way, if you go back into your past, you don't want to prevent your parents from meeting each other. That would kind of mess things up. Because then you wouldn't exist to then go back in time to prevent your parents from meeting each other. Yes.
My question to you is, Arthur C. Clarke just died, and of course he was a great scientist before he was a great science fiction writer. And I have a feeling that any science fiction movie you see, you'll be unhappy with. So how about writing one?
That has actually crossed my mind. However, my writing training is more in sort of the exposition of science rather than in the sort of the dramatic interplay of personalities and love stories and that sort of thing. So I don't claim the talent that an actual storyteller would have to convey a science fiction story. What I would be happy to serve as a science advisor to a writer who actually has that talent and that interest. I could play that role extremely well. But doesn't mean I couldn't learn how to sort of be a creative writer in that regard, but I would have to save that for all of my copious free time that I have in the day. So it might be like a retirement project for me, but I think it's not anytime soon. But like I said, I'd be happy, and I do advise writers. I don't need credit for it even. I just like the celebration of science, and science fiction writers are part of this buoyant force that keeps science alive in the hearts and minds of the public. So I get calls and emails all the time. I'm thinking about a story on a star and it explodes. What'll happen to the spacecraft? They say it'll vaporize. Okay, well, what'll happen to the... And so we go through a dialogue, sharpening and improving the storyline. And so I've done that. I've helped others out. But thanks for that suggestion. And I'll be waiting. You'll be waiting, okay.
Were you a fan of Arthur C. Clarke?
Yes, I was, although I read much less science fiction than others of my colleagues. I was so thoroughly enchanted by science fact that there was no room left in me for science fiction. And once I learned about black holes and the expanding universe and colliding galaxies and the search for life, and I was done. You know, what's left in me to then read science fiction?
Who needs to make anything up at that
Right,
point?
exactly. So, but I have no less respect for that enterprise, no pun intended, the enterprise. And no, I do have a, I know the Trek, I can hang with the Trekkies out there. My sideburns are like Trek sideburns. They go, I don't know if you noticed, they go to a point. Go check them out, the Spock Star Trek thing. That's my little homage to the Star Trek generation. But with Arthur C. Clarke, what distinguished him from other visionaries, they're like the tech visionaries. Oh, in 10 years we'll all have something in our car or in our home. He wasn't that trite, because he not only understood the trajectory of technology and science, he understood human behavior. And it is the intersection of human behavior with technology that is society. And that's where he distinguished, that's where his predictions and accountings for what the future would look like and smell like, that's what distinguished him from everybody else that was out there just predicting what new gadget we would have in the future.
And I think it's worth mentioning, too, that within days of the passing of Arthur C. Clarke, we had one of the most enormous explosions in the history of the universe, a naked eye gamma ray burst, which is really quite extraordinary.
So you think that was the universe reacting to his death? Is that right?
Possibly. I'm not saying, maybe.
Arthur C. Clarke was actually the first interview that I ever did when I started my career on NOVA for a film I made on artificial intelligence called The Mind Machines. One tiny little anecdote, I was a complete rank beginner. I was going to New York to do this interview. I'd been shooting all day, and I asked him where he was staying because I thought I'd stay in a hotel nearby. And he said that he stayed at the Hotel Chelsea, way downtown in New York. Now, the Chelsea is not really all that pleasant a place. In fact, many people have called it, even though many literary works have been written there, including Under Milkwood, it's kind of a flop house. So, but I didn't know what it was. I didn't live in New York, so I went down there. And the night before this interview, when I should have gotten a great rest, I was sleeping in a room with 12 unmade beds. It was really kind of a creepy place, but Clarke was completely made up for that. He wrote 2001 there and many other of his books, and he had a sentimental tie, as many authors do, to the Chelsea. That's why he stayed there. He was a fantastic interview, fantastic.
That's great. That's great. We're starting to wind down, so we've got time for a few more. Do I see some hands? You got to get to the microphone. Who? And
the balcony. We need some balcony questions.
Why don't you repeat that question?
Do I believe in UFOs or extraterrestrial visitors? I'm not authorized to answer that question. Where shall I begin? UFO. First, remember what the U stands for in UFO. Now, there's a fascinating frailty of the human mind that psychologists know all about, and it's called argument from ignorance. And this is how it goes. You ready? Somebody sees lights flashing in the sky. They've never seen it before. They don't understand what it is. They say, a UFO. The U stands for unidentified. So they say, I don't know what it is. It must be aliens from outer space visiting from another planet. Well, if you don't know what it is, that's where your conversation should stop. You don't then say, it must be anything. Okay? That's what argument from ignorance is. It's common. I'm not blaming anybody. Psychologists know all about it, and it may relate to our burning need to have to know stuff because we're uncomfortable, steeped in ignorance. You can't be a scientist if you're uncomfortable with ignorance, because we live at the boundary between what is known and unknown in the universe. Unlike what journalists write. You ever see journalists? Any journalists here? You go to journalists. You go to journalists. All articles about science discoveries begin. Scientists now have to go back to the drawing board. As though we're sitting up in our office, you know, masters of the universe. It's like, oops, somebody discovered something. No, we're always at the drawing board. If you're not at the drawing board, you're not making discoveries. You're something else. So, the public, it appears, seems to have this burning need to have an answer to what is unknown. And so you go from an abject statement of ignorance to an abject statement of certainty. So, that is operating within us. Let's start there. Second, we know, not only from research in psychology, but simple empirical evidence in the history of science, that the lowest form of evidence that exists in this world is eyewitness testimony. Which is scary because that's some of the highest form of evidence in the court of law. But we know from second grade. Where's my guy from second grade? Get up to the microphone for a minute. Grab the microphone. Grab the microphone. In your classes, have you done the famous experiment where you play telephone and you line up all your kids in class and one person starts with a story and then you hear it and you repeat it to the next person and the next person? Have you done that in class yet?
Yes.
You've done that experiment? Because what happens by the time you get to the last person and they retell the story? What happens?
It's like completely different.
It's completely different. Completely different, okay? Because the conveyance of information was relying on eyewitness testimony, which in that case is ear witness testimony. And so, thank you. So we know that. So he knows it. He's in second grade. All right. So, actually he should be in 12th grade as we've established. So now, it wouldn't matter if you saw a flying saucer. In science, even if you have something less controversial than a flying saucer, if you come into my lab and you say, you got to believe me, I saw it, and you're one of my fellow scientists, I say, go back, go home. Go back until you have some other kind of evidence that's not just you saw it. Okay? Because human perception system is rife with all ways of getting it wrong. Okay? But we don't like thinking of ourselves that way. We have high opinions of our human biology when in fact we should not. I'll give you an example of how it reveals itself. We've all bought and enjoyed books called Optical Illusions, right? Well, we all love optical illusions, but that's not what they should call the book. They should call them brain failures, okay? Because that's what it is. It is a complete failure of human perception. All right? All it takes is a few sketches that are cleverly done. Your brain can't figure it out. All right? So, We are poor data-taking devices. That's why we have such a thing as science, because we have machines that don't care what side of the bed they woke up in the morning, don't care what they said to their spouse that day, doesn't care whether they had their morning caffeine. They'll get the data right, okay? So, maybe you did see visitors from another part of the galaxy. I need more than your eyewitness testimony. And in modern times, I need more than your photograph, which Photoshop probably has a UFO button today. Like, stick it in, right? So, on your computer. So, here's what you do. I'm not saying we haven't been visited. I'm saying the evidence thus far brought forth does not satisfy the standards of evidence that any scientist would require for any other claim that you're going to walk into the lab with. So here's what I recommend. Next time you're abducted, because I'm ready for this. I'm ready, okay? I get abducted, I'm ready, okay? So you're there, you're like on the slab, because they always do like the sex experiments on you, on the flying saucer. So there you are, and they're poking at you. Here's what you do. You ready? You tell the alien, you're going to be an alien for this, right? So you're poking me, all right? So then I say,
I'm on this side of the equation.
Okay, so I say, hey, look over there. And then he looks over there, you quickly like snatch something off the shelf, put it in a pocket, and then lay back. All right? Then you're done, you come back, and say, look what I got. Okay, I like stole the ashtray off the shelf of the flying saucer. And then you bring that to the lab. And it's not about eyewitness testimony at that point, because you'll have something of alien manufacture. And anything you pull off of a flying saucer that crossed the galaxy is going to be interesting. Okay? Because even objects within our own culture. I got this device here, okay, the iPhone. 10 years ago, they would have resurrected the witch-burning laws had you pulled this thing out, okay? And that's in our own culture. Our own culture produced this over a 10-year span. So if there's some technology that crossed the galaxy, that's going to be some serious stuff to look at in the lab. Then we can have the conversation. Until then, I can't, I'm sorry. Go ahead, keep trying to find them. I'm not going to stop you. But get ready for that time you are abducted, because I'm going to be looking for your evidence when that happens. And last point on that is, there are people who look up all the time. Like, for example, the community of amateur astronomers in the world. I was an amateur astronomer. We come out of a building, we look up. Doesn't matter, we're looking up. UFO sightings are not higher among amateur astronomers than they are in the general public. In fact, they're lower. You say, well, why is that so? Well, because we know what the hell we're looking at. We know. Do you know? I don't. Because we study this stuff. Do you know there was a UFO sighting reported by a police officer, because we think that because you have a badge or you're a pilot or you're whatever, that your testimony is somehow better than that of an average person. It's all bad because we're human, okay? So there was a police officer who was tracking a UFO that was swaying back and forth in the sky. Okay, reported on the hot. They're in one of the, what do you call the car? The squad car chasing a UFO, and the UFO's moving back and forth like this. Okay. Later, it turned out the cop car was chasing Venus, and he was driving on a curved road, but was so distracted by Venus, he thought Venus was the one moving, and he wasn't even thinking that he was doing this. So, I have seen things which, without my background in meteorology and astronomy and looking up, I would have reported to the police department. I would have. Like orographic clouds that form above huge mountains that are circular. And they're above a tall mountain, which means wherever you are, the sun can set for you before it has set for the cloud, darkening the skies, yet the cloud is now illuminated by sunset colors, which are what? Red, yellow, orange, and it's circular. There have been reports of hovering circular UFOs with light beams on them because people are looking at this cloud formation on top of mountains. So, maybe we have been visited by aliens. Maybe they've even landed. But why do they land in like the farmer's yard and not like Times Square, all right? And then I worried, like maybe they had landed in Times Square, but nobody took notice. You know, because that's the really big problem there. And so there's a huge answer to it because there's a lot built into it. So here's another concern I had. Oh, you said about movies earlier? Remember Close Encounters of the Third Kind?
Absolutely.
Remember that? And the aliens come in this big flying saucer?
Sure.
Okay, and what do? We turn on runway lights for it. I'm thinking, flying saucers don't need runway lights. They're flying saucers, for goodness sake. If you put a bullseye or something.
You didn't need them when we landed on the moon.
Don't put runway lights for this thing. Then, when you go to Roswell and there's like crashed flying saucers, I'm thinking, if the alien came across the galaxy and couldn't land a damn spaceship, I don't want to meet the aliens. They're stupid aliens, all right? You at least land on Earth, for goodness sake. Don't tell me you came across the galaxy, you can't land on Earth? Go home. Bring me somebody who can, then I'll have the conversation. Anyhow, so those are my opinions on the subject. I'm sorry.
We've got about 5 more minutes, so 5 more minutes. And maybe time for 1 or 2 more questions.
Yeah, so try not to be on the fence here. Are you for or against string theory?
String theory. Well, you know, I was all for it back when they started that adventure back in early 80s, in 1982. And in fact, at the time I was at the University of Texas, where some of the leading thinkers at the time were based. And string theory is like the theory of everything. It would get you an understanding where Einstein's theories end and pick up it would allow you to divide by 0 legally, okay? That's what string theory would allow you to do. It'll allow you to describe the universe at the moment of the Big Bang, which is where right now our theories can't get us there, possibly even before the Big Bang. It would unify the science of the large, general relativity, with the science of the small, quantum mechanics. All right, if that's the case, fine. I asked him, how close are you? They said, a couple of years away, we're almost there. So 1985 rolls by. Oh, how's it going? We're going well. How close? Oh, a couple of years away. They've been saying a couple of years for 27 years, 26 years. So I'm kind of losing enthusiasm. But they're the only game in town. And they're really cheap to fund. Like a pencil, a pad, throw in a laptop. They're good. You send them off to their office, let them do their thing. I don't have a problem with that, because they're the only game in town. I'm not going to stop them, but I'm losing my enthusiasm. And you ask them, they say, it's a very hard problem. Now, again, the book was titled Optical Illusions, Not Brain Failures. So a string theorist will not say, we are all just too stupid to figure this problem out. But maybe we as a species are too stupid to figure it out.
Keep the thing.
If it's cheap, I will. Yes, I'm not going to start directing funds from other research that might have a shorter time horizon for the discovery of what they're after. I'm yanking it like that. But like I said, they're inexpensive, and there aren't many of them, and they're harmless. Yeah, the question, yes. Well, those are like the particle physicists. You know, you always got to give the particle physicists their next accelerator. And they're driven by more than just whether they find the string theory particles. But yeah, sir. Mm-hmm.
I'd like to ask you kind of a hypothetical. If black holes...
like falling into a black hole was not hypothetical? Are you the only hypothetical? Like meaning aliens was not hypothetical? Sir, you're not the only hypothetical question this evening, okay?
Well, I just thought I'd preface it that way.
Okay.
If black holes didn't exist, would the universe as we know it exist? And if that's the case, is that just another example of a finely tuned universe?
The black holes, as far as we know, don't play any fundamental role in the universe. Most of the universe goes on just fine without ever looking at, thinking about, smelling a black hole. So what black holes do is enable us to explain a lot of what would otherwise go unexplained, like the engines that drive what we call active galaxies. These are galaxies that are the engines of quasars, for example. We have no accounting for those but for black holes. The behavior of stars in the centers of galaxies. We need black holes to account for those. But if you took away all those black holes, it's not obvious the universe would care at all. It would still could happen just the way it did. So they're rare enough so that it's hard to think of them as fundamental. Could you get closer to the microphone?
Oh, except that maybe that's where the dark matter is.
Oh, well, yeah, because black holes are dark and things. However, we've already counted for all the black holes in the ordinary matter part. And then, because black holes are ordinary, they do things to light, and dark matter does not interact with matter or energy or light or anything that is in our universe in any way at all. It's as though we're not even there. It's quite embarrassing, actually, but we're completely ignored by it.
So in no way could, say, like nano black holes or micro black holes account for the missing matter.
The nano black holes would evaporate very quickly, and we would see them explode. We would see sort of bursts of those around the universe, and we don't see that. So nano would be small. That's how you're using that adjective. So no, you can't hide it in ordinary matter. Dark matter is a completely different species of object. We've accounted for all the ordinary matter that there is.
I'm sorry, we're this one right here, and then we're out. I'm afraid.
Given the curvature of space-time, what is the shape of the universe? If space and time are curved, what is the topology and the shape of the universe?
Well, the universe, given the distribution of matter, which is it's statistically uniform, so the observable universe is a sphere. You look in every direction, you hit our horizon at about 14 billion light years out. And that's artificial in the sense that when you're a ship at sea and you look out to your horizon, you're not saying that's the whole ocean right there. No, that's the ocean that you can see. If you move to another spot, more ocean comes into view. If we were in another part of the universe, we'd see a horizon corresponding to that spot rather than to ours. So in that simple sense, we are spherical. Our rate of expansion, however, is such that if you want to think of the geometry of the curvature, we're in a one-way trip expanding that'll never come back, and that is what we call negatively curved universe. And a negatively curved space is what we call a saddle shape. When you're negatively curved, there's no coming back on itself. So that's our shape.
I think we're going to have to go on to your closing little puzzle. I appreciate
it has
everybody.
like a thing.
I'm a second grade teacher, that's why I'm being so pushy. I'm supposed to hand
You're a
deliver
second grade teacher, that's cool. Teachers
letters.
are like the heroes of the world. Okay.
I promised I would bring them. They worked really hard on these letters, and I just wanted to deliver them.
These are letters to me?
Mm-hmm.
Oh, that's sweet.
They came up. They only had one.
Okay. Okay. So that's the science lecture version of tossing flowers on the stage. Is that right? Is that what that is?
They were
letters from second. I'm deeply touched.
They were upset that you were getting such negative letters, and so they wanted to write you letters from other scientists. And to come up with a question from 27-year-olds was hard. They just wanted to know, what are you most passionate about in your job?
What in my job am I most passionate about?
Yes, and I know we're in a hurry, but if I didn't deliver those, I would be dead.
Okay, thank you. Most passionate. Well, I have several passions in life, but I would say one of them is, on the public side, is trying to raise the level of science literacy a few notches in the electorate. I think that's fundamental to the future of the nation.
Can we also have a hand for our panel? You got one more
thing. Can I leave you that?
You may.
That disturbing thought that will keep everyone awake at night.
Please do.
May I? Yeah. Okay. You sure? I'm not accountable if you can't get to sleep tonight. Okay? It's what? Oh, to move back. Okay, yeah. We could come back here. So. There. Okay.
I'm safer back here.
No. Okay. All right. So I can see everybody. We got everybody. You guys over here. You're good troopers. Looking at the back of his head here, right? Yeah. Okay. Good. All right. Just a couple of thoughts. One that's sort of deeply cosmic and another one that is fascinatingly disturbing, I think. But you'll be the judge of this. Consider a couple of fundamental facts that has been gleaned in the past 60 years. that the ingredients, if you had asked your chemistry teacher 50 years ago, once you looked at that mysterious chart of boxes that sat in front of your class, the periodic table of elements, where did those elements come from? The chemistry teacher would actually not have an answer for you. They'll say, well, we dig them out of the earth. That's not where they come from. It took modern astrophysics to determine the origin of the chemical elements. We observe stars. We know what goes on in their center. They explode, laying bare their contents. And what we have discovered is that the elements of the periodic table, that which we are made of, derive from the actions of stars that have manufactured the elements, exploded, scattered their enriched guts across the galaxy, contaminating or enriching gas clouds that then form a next generation of stars populated by planets and possibly life. And so, when you look at the ingredients of the universe, the number one ingredient is hydrogen. Next is helium. Next is hydrogen, helium, oxygen, carbon, nitrogen. Those are the top ingredients in the universe. Now you say, well, okay, that's kind of cool. Well, and you look at Earth, because we like thinking of ourselves as special, we say, oh, we're special. Well, what are we made of? Well, what's the number one sort of molecule in the body? It's water. It's water. Well, what's water made of? H2O, hydrogen and oxygen. Hydrogen and oxygen. In fact, if you rank the elements in the human body, with the exception of helium, which is chemically inert, useless to you for any reason other than just to inhale it and sound like Mickey Mouse, you can't die from helium unless that's all you breathe. Number one in the human body is hydrogen. Matches the universe. Number two is oxygen. Matches the universe. Number three, carbon. Matches the universe. Number four, nitrogen. Matches the universe. And for each of us, the fifth element, other, is the same in both places. Okay? Other. So, we learned in the last 50 years that, of course, not only do we exist in this universe, it is the universe itself that exists within us. And had we been made of some rare isotope of bismuth, you would have arguments, hey, we're something special. But there are people who are upset by that fact, saying, well, that mean we're not special? Well, I think it's special in another kind of way. Because when you look up at the night sky, it's no longer we're here and that's there. It's that we are part of that. And that association, for me, is actually quite enlightening and ennobling and enriching. In fact, it's almost spiritual, looking up at the night sky and finding a sense of belonging, given what we've learned about the night sky. And so now we have ourselves. Now, are we alone in the universe? We're made of the most common ingredients there are. And our chemistry is based on carbon. Carbon is the most chemically active ingredient in the entire periodic table. If you were to find a chemistry on which to base something really complex called life, you would base it on carbon. Carbon is like the fourth most abundant ingredient in the universe. Isn't that rare? You can make more molecules out of carbon than you can all other kinds of molecules combined. So if we ask ourselves, are we alone in the universe? It would be, in spite of my diatribe about UFOs, I tell you in the same breath that it would be inexcusably egocentric to suggest that we are alone in the cosmos. The chemistry is too rich to declare that. The universe, too vast. There are more stars in the universe than grains of sand in all the beaches of the world. There are more stars in the universe than all the sounds and words ever uttered by all humans who have ever lived. To say we're alone in the universe. No, we haven't found life outside of Earth yet. We're looking, haven't looked very far yet. Galaxies this big, we looked about that far. But we're looking. And how about life on Earth? How is it hard to form? Just because we don't know how to do it in the lab doesn't mean nature had problems. So it may be, given that information, that given the right ingredients, which are everywhere, life may be inevitable, an inevitable consequence of complex chemistry. If that's the case, we look around our own solar system, we look at Mars. All the evidence suggests that Mars was once a wet, fertile place, an oasis. There are dried riverbeds and floodplains and river deltas and meandering rivers. It's all bone dry now. Something bad happened on Mars. Some knobs got turned in its environment that left it the way it is right now. Some bad knobs got turned on Venus too. Runaway greenhouse effect. You saw the clip on that. 900 degrees Fahrenheit on Venus. Some knobs got turned there too. People say, why spend money up there when we spend it? Because up there we might learn about down here, okay? I don't want a runaway greenhouse effect here. Venus is the best example in the solar system of a planet gone bad. Let's learn about that first. So, it turns out we learned that asteroid impacts, when they hit, can cast rocks in the surrounding areas into space with escape velocity, so they never come back to the planet from which it was launched. If Mars was wet and fertile before Earth was, as all evidence suggests, and if Mars had life before Earth had life, it is possible for there to have been bacterial stowaways in the nooks and crannies of the rocks that were cast into space. There's some hardy bacteria that we already know exists on Earth. Survives extreme temperatures, pressures, freeze-dried, reconstituted, radiation. The hostile environment of space would be nothing to some of these bacteria. It may be that life on Earth was seeded by bacterial stowaways on rocks that were cast free from Mars. This is a plausible scenario that's called panspermia, the transference of life from one planet to the next. If that's the case, that makes all of us descendants of Martians. I want to alert you in advance. Now, let me give you a disturbing thought. A fascinatingly disturbing thought, and we'll leave you on that note. If you look at our closest genetic relative to human beings, it would be the chimpanzee. We share like 98+% identical DNA. We are smarter than a chimpanzee. So let's invent a measure of intelligence that makes humans unique. Let's say intelligence is your ability to compose poetry, symphonies, do art, math, and science, let's say, okay? Let's make that as the arbitrary definition of intelligence for the moment. Chimps can't do any of that. Yet we share 98, 99% identical DNA, okay? The most brilliant chimp there ever was maybe can do a little bit of sign language. Well, our toddlers can do that. Toddlers. So here's what concerns me deeply. Deeply. Everything that we are that distinguishes us from chimps emerges from that 1% difference in DNA. It has to, because that's the difference. The Hubble telescope, these that's in that 1%. Maybe everything that we are that is not the chimp is not as smart compared to the chimp as we tell ourselves it is. Maybe the difference between constructing and launching a Hubble telescope and a chimp combining two finger motions as sign language, maybe that difference is not all that great. We tell ourselves it is, just the same way we label our books optical illusions. We tell ourselves it's a lot. Maybe it's almost nothing. How would we decide that? Imagine another life form that's 1% different from us in the direction that we are different from the chimp. Think about that. We got 1% difference and we're building the Hubble telescope. Go another 1%. What are we to they? We would be drooling, blithering idiots in their presence. That's what we would be. they would take Stephen Hawking and roll him in front of their primate researchers and say, well, this one is like the most brilliant among them because he can do sort of astrophysics in his head. Oh, isn't that cute? Little Johnny can do that too. Oh, that's so nice. Oh, in fact, Johnny just did that. Let me get it. It's on the refrigerator door. Here he is. He did it in his elementary school class. Think about how smart they would be. Quantum mechanics would be intuitive to their toddlers. Whole symphonies would be written by their children and, like I said, just put up on the refrigerator door the way our pasta collages are on our refrigerator doors. So the notion that we're going to find some intelligent life and have a conversation with it? When was the last time you stopped to have a conversation with a worm? Or bird? Oh, well, you might have had a conversation, but I don't think you expected an answer, all right? So, we don't have conversations with any other species on Earth with whom we have DNA in common. To believe that some intelligent other species is going to be interested in us enough to have a conversation? They'll look at our Hubble telescope and say, oh, isn't that quaint? Look at what they're doing. So I lay awake at nights wondering whether simply we as a species are simply too stupid to figure out the universe that we're investigating. And maybe we need some other species, 1% smarter than we are, for which string theory would be intuitive, for which all the greatest mysteries of the universe, from dark matter, dark energy, the origins of life, and all the frontiers of our thought would be something that they would just self-intuit. I'm jealous of that possibility because I want to be around for those discoveries. Thank you all.